Hello, everyone. Welcome back to the Math Mindset. And today we're going to be going over a set of SAT geometry problems pulled straight from the College Board SAT question bank online. After talking to a bunch of friends and people from, my community, I found that SAT geometry was often the most confusing subject on the math section of the digital SAT. And I thought I wanted to help you guys out there preparing for the June SAT or for SATs in the future with some of the hardest problems that College Board has to offer regarding geometry and trigonometry concepts. Right? I recommend that you pause the video and try some of these problems yourself before looking at my solutions. And without further ado, let's get into the problems. So we'll start with problem number 1. And problem number 1 reads, in the figure, AC is equal to CD. The measure of angle EBC is 45 degrees, and the measure of angle ACD is 104 degrees. What's the value of X? Okay, first, we're going to label everything on the diagram. So they tell us angle EBC is 45 degrees, right? And they tell us angle ACD is 104 degrees. And they want us to find the value for X. Right? C equals CD. Kind of game. Now, in these kinds of problems, it's usually helpful to pick out relationships between angles that are very common in these kinds of problems. Usually supplementary angles, sometimes complementary angles. Some of angles in a triangle, angle relationships between parallel lines. What I'm talking about is alternate interior angles, alternate exterior angles, etc. Just be on the lookout for angles that share those kinds of relationships, and when you're solving a problem where you have to find some angle. Right here, I already see supplementary angles. Angle DCA and angle BCA are supplementary. So those two have to add to 180. So angle BCA is just 180 minus 104, 76. Right? And here, this angle right here, if we look at triangle, I'm going to call this point of intersection X. If we look at triangle BCX, right here, this angle is 45, this angle is 76. We don't know this angle, but we do know that the sum of the angles in the triangle is 180 degrees. So the question mark angle is just 180 minus 45 minus 76. It's just 135 minus 76. And that will be 59 degrees. That value. Right? And then zooming in on triangle XEA, this angle X right here is just 59 degrees by the vertical angles theorem. Right? And if you look at triangle CDA, we know this angle is 104. And by the properties of isosceles triangles, the angles opposite the sides that are the same, those angles will be the same as well. So that means these two angles are the same. Right? So if we call this angle Y and this angle Y, we know 104 plus 2Y is 180. 2Y is equal to 76. That means Y is equal to 38. So this angle is 38 degrees, and so is this angle. So now we know that this angle in triangle XEA is 38 degrees. And this angle is what we're looking for, angle X. So that angle X will be equal to 180 degrees minus 59 degrees minus 38 degrees, which if you do the math will turn out to be 87 degrees. So our value for X is just 80. Oh no, wait. This should be 83. Sorry, I did some subtraction mistake. That should be 83 degrees, guys, because it's 180 minus 97. Yep, that's 83 degrees. And that's our answer. Here we are with another angle chasing problem. In the figure shown, points Q, R, S, and T lie on the line segment PV, and line segment RU intersects line segment SX at point W. The measure of angle SQX is 48 degrees. Let's mark that down. 48 degrees. And the measure of angle SXQ right here is 86. Right? And the measure of angle SWU is 85. Right? And the measure of angle VTU is 162. What is the measure in degrees of angle TUR? So this angle, we want to know what that is. Right? So first, let's find this angle. You know, angle STU and angle VTU are supplementary. So angle STU is just 180 minus 162, or 18 degrees. Now let's draw our attention to triangle QXS. This angle right here is 86. This is 48. And this is an angle we want to know what that angle is. So the angle we want to know right now is 48 plus 86. Right? And we have to subtract that from 180. So it's just 180 minus the quantity 48 plus 86. That'll be 134. So that angle is 46 degrees. So right here. Now again, if we find angle TSW, that angle will be 134 because that angle and the 46 degree angle are supplementary. Now we can shift our attention to quadrilateral SWUT. We know 3 of the angles in that quadrilateral. We know this angle is 134, this angle is 85, and this angle is 18 degrees. Now the sum of the angles in a quadrilateral is 360 degrees, right? So if we want to find what we've been looking for this whole time, angle TUW, or TUR as they say it in the question, both are the same angle, right? We can do 360 minus 85 minus 134 minus 18 to find that angle, right? So we get to 360 minus 219 minus 18, 360 degrees minus 237 degrees, or 123 degrees. That is the measure of angle TUR. Right? Moving on. Here we go. Intersecting lines R, S, and T are shown below. What's the value of X? So in these kinds of angle chasing problems where they ask you to find an angle X, right? Usually you look for the sum, you apply the property that the sum of the angles in a triangle is 180 degrees. You look for supplementary angles. And you sometimes look for parallel lines that can tell you relationships between angles that are on the same side of the parallel lines, on the opposite sides, right? Stuff like that. So here, immediately, we notice we got a pair of supplementary angles. This angle will be 74 degrees, because 180 minus 106 is 74 degrees. And then here, we have ourselves a nice triangle. So this angle right here that I've just drawn in black will be 180 minus 74 minus 23. That'll be 100. 100. Okay, let's see. This is equal to 180 minus 97. It'll be 83 degrees. 83 degrees, right? So X is just 180 minus 83 degrees. It's 97 degrees. So our X value is just 97. Okay, let's move on to the next question. A cube has an edge length of 68 inches. A solid sphere with a radius of 34 inches is inside the cube such that the sphere touches the center of each face of the cube. So what we're getting at is that the sphere is essentially inscribed in this cube. Right here. So the sphere, it can look something like this. Center might be right here. The radius is 34. not 34 degrees, it's just 34 inches. And we want to know what's the volume of the space in the cube not taken up by the sphere. So we just have to subtract the two volumes to find out what that is. So let's subtract the volume of the cube minus the volume of the sphere. That'll just be 68 cubed because the volume of a cubed is the side length cubed. Minus, if we apply the formula for the volume of a sphere, it's just 4 over 3 times pi times the radius cubed. In this case, it's 34. And if you run this in the calculator, just give me a second to do that. 68 cubed minus 4/3 pi times 34 cubed. Yes, if you round this answer to the nearest whole number, you end up getting option A, 149,796. All right, let's keep going. The next question says points Q and R lie on the circle with center P. Okay, so let's draw the circle. Here's our center P, and we have points Q and R. Right, like that. And we're given information about a triangle PQR, so let's draw that in as well. We're told that it has a perimeter of 31 inches, and we want to know what QR is. Okay, in the diagram, like I've drawn above, it's pretty clear that PQ and PR are radii of the circle, so they're the same length. They have length 9. And in order to find QR, well, we can take the perimeter equation, PR plus PQ plus RQ, and we can set it equal to what they tell us it is. It's just 31. Now, PR plus PQ is just 9 plus 9 plus QR, which is what we want to know, is 31. Subtracting the two 9s from both sides, we get QR is just 13. That's our answer. Okay, let's keep going. All right, we have a circle equation, circle question. A circle in the xy plane has its center at -1, 1. Line T is tangent to this circle at the point 5, -4. Which of the following points also lies on line T? All right, let's draw our circle. Right here, we have our point, our center point, -1, 1. And let's just say this is the point of tangency. This is 5, 4. I'm going to draw our tangency line. Give me 1 second. Let's draw a line. It's tangent. Right? That's our line, guys. This is line T. And we want to know which of the following points lies on line T. Well, in order to find out what one of those points could be, we have to find out an equation for line T. We have to find out its slope, and then we have to plug in the point on that line to find out an equation for it. But how do we go about doing that? Well, in this diagram, the only other segment that I can construct, is a segment from the center to the point of tangency. Like this. This line right here. Right? And it's a well-known property for circles that the segment connecting the center of that circle to the point of tangency is perpendicular to the tangent line. Right? So in this case, the line segment connecting the points -1, 1 and 5, -4 is perpendicular to our line T. So if we just find the slope of our line segment, I'm going to call it S, we'll find the slope of line T because it's just a negative reciprocal because the two lines are perpendicular. And in that way, we can find an equation for line T. So our slope for the segment is y2 minus y1 over x2 minus x1. That's, let's see, -4 minus 1 over 5 minus -1. That's -5 over 6. So that means the slope of line T is the negative reciprocal, which is 6 over 5. Right, using the point slope form for a line, we get this equation for line T. Y plus 4 is equal to 6/5 x minus 5. Isolating y, we get y equals 6/5 x minus 6 minus 4, which means that the equation for line T is y equals 6/5 x minus 10. So our equation for line T is this, y equals 6/5 x minus 10. Now we just have to find out which one of these points passes through it. Clearly not A. Our y-intercept isn't 6/5. If we plug in x equals 4, we'll get a fraction because 4 is indivisible by 5, so we're left with a fraction. And we won't get a whole number. So B is off the charts. Same problem with D. So C is the only option left. Let's just make sure it works. Right, 2 should be equal to 6/5 times 10 minus 10. It's equal to 12 minus 10, which is indeed equal to 2. So the point described by option C indeed works. So that's our correct answer. Let's keep going. Alright, this figure is quite small. Let me redraw it down here. Okay, not what I wanted. Let's keep that. So this is point M, N, this is M, this is R, this is Q, this is P. Okay, this angle is 70 and this angle is 60. Okay, now let's look at the question. In the figure above, MQ and NR intersect at point P. NP is equal to QP. So this segment is equal to this segment. And MP is equal to PR. So these two segments are congruent to each other. What's the measure in degrees of angle QMR? So QMR. So this angle right here. We want to know what that is. Here I see a pair of supplementary angles. Angles MPR and angles QPR are supplementary. So the measure of angle MPR is just 180 minus 60, which will be 120 degrees. And again, here using the properties of isosceles triangles, the angles opposite the sides that are equal will also be equal. And here we can just sum the angles in triangle MPR. So 120 plus, the angle we want to find x, plus the other angle, which will also be equal to x, has to equal 180. All right, so subtracting 120, we get 2x equals 60. Therefore, x, which is the measure of angle QMR, is 30, right? It's 30 degrees. That's the answer to our question. Let's keep going, guys. In triangle XYZ, angle Z is a right angle and the length of YZ is 24 units. If tan x equals 12 over 35, what's the perimeter in units of triangle XYZ? Okay, here we're introduced to the concept of trigonometric ratios. Right, let's see how we can apply those to solve this problem. Okay, let's draw our triangle XYZ. So this is X, Y, Z. Or they said Z is the right angle, right? So this is Z and this is Y. So Z is the right angle. The length of YZ is 24. If tangent of X is 12 over 35, what's the perimeter in units of triangle XYZ? Okay. So if you haven't heard of the mnemonic SOHCAHTOA already, I'll explain what that is. For most of us, this mnemonic has been taught to us by our geometry teachers in order to help us memorize what sine, cosine, and tangent represent in a right triangle. So the sine of an angle in a right triangle, x, is the opposite side over the adjacent side. The cosine of that same angle, or opposite side over hypotenuse, I should say. Cosine of the same angle is adjacent over hypotenuse. The tangent of that same angle is the opposite side over the adjacent side. Here we're given tangent, so let's apply this ratio right here. So if tangent x is equal to opposite over adjacent, our opposite side is side YZ, it's 24, and our adjacent side is XZ, and that is supposed to be equal to 12 over 35. Right, cross multiplying, we get 24 times 35 equals 12XZ. Divide by 12 on both sides, and you get 70 equals XZ. So we know what XZ is. We want to find the perimeter, though, so we have to find what XY is. Use the Pythagorean theorem over here. XY squared equals 70 squared plus 24 squared. Taking the square root of both sides, you get XY is equal to, let me put this into my calculator. 70 squared plus 24 squared. Yeah, this equals 74. XY equals 74. Now we can add the three sides up to find our perimeter. So the perimeter is just 74 plus 24. This will be 98. And then we have to add 70. That'll give us 168. It's choice B. Alright, a right square prism has a height of 14 units. The volume of prism is 2016 cubic units. What's the length in units of an edge of the base? So they tell us that our figure is a right square prism, meaning that the base is a square. Right? We don't know what length it is. And then we're also told that the height is 14. So clearly the volume of this prism will be length times width times height, which will be s times 14, or 14s squared. We're told what the volume is. It's 2016. So we can equate the two expressions. 2016 equals 14x squared, s squared, divided by 14 on all sides. You get 144 is equal to s squared. Take the square root on both sides. You get 12 is equal to s. So that's the length of an edge of the base. Okay, let's keep going. Square A has side lengths that are 166 times the side lengths of square B. The area of square A is k times the area of square B. What's the value of k? All right, so let's imagine we have our square B right here. This is B. Say it has side lengths of s. Right, and then we have our square A. Obviously, this isn't to scale. And it's got sides of length 166s. Right? And they tell us the ratio. They want us to find the ratio, rather, of the areas of the two squares. So they want us to find the area of square A over the area of square B. Right? So we can find that very easily. It's just 166s times 166s over the area of square B is just s times s. This ratio is 166 squared, which if I multiply this out, give me 1 second, 6, 3, 9, 9. Add it up. 10, 19, 25, 17, 2. This is equal to 27,556. That's our answer for this question. Okay, we'll end on this question for this part of the video series. In the next part of the video series, we'll continue the problem set. Okay, this is a good problem to end on. I encourage you to pause the video and try this out for yourself before I try this problem and reveal the solution. It involves a bunch of triangle concepts. It involves similar triangles, some trig ratios. So yeah, I recommend you try this out before you see the solution. In triangle ABC, the measure of angle B is 90 degrees and BD is an altitude of the triangle. The length of AB is 15 and the length of AC is 23 greater than the length of AB. What's the value of BC over BD? Okay, so we have our triangle ABC. Okay, B is our right angle and BD is an altitude. So if BD is an altitude, that means it's perpendicular to the side it hits, right? So the two angles I just marked, angle ADB and angle BDC, they're right angles. The length of AB is 15 and the length of AC is 23 greater than the length of AB. So it's just AC is just 15 plus 23, that's 38. And we want BC over BD. BC over BD, right? Since we're asked to find a ratio between two sides of a triangle, that tells us one of two things. That tells us either we can use trigonometric ratios, sine, cosine, tangent, whatever it is, to help solve this problem, or we can use similar triangles to help solve this problem. Here I'll present a solution using, the trigonometric ratios to solve this problem, but if you want to investigate and see how you'd use similar triangles to solve this problem, you can do that as well. Actually, the solution is pretty similar. I think it's just one extra step after defining the similarity ratio. It's just about writing the right ratio down in order to find the ratio of BC to BD. But anyways, let's get started. Right here, if you notice, triangles BDC and triangle ABC share this angle C here that I've outlined in black, right? They also share a right angle, right? They also have a right angle, which means that this angle, angle DBC, is congruent to angle BAC, which means we have some similar triangles on our hands, right? We have triangle ABC is similar to triangle BDC. Now, the reason why I'm showing you that these triangles are similar is to be able to use the trigonometric ratios related to sine C to find BC over BD. I can use those ratios now, right? We want BC over BD. So let's focus on triangle BDC. That's where the two sides are, right? BC over BD, right? BC is the hypotenuse because it's opposite the right angle. And BD is the opposite side to angle C. Now, if you notice, hypotenuse over opposite is just 1 over opposite over hypotenuse, which means it's 1 over the sine of whatever angle we're referencing the sides from. In this case, 1 over sine C. So the ratio we want is just 1 over sine C. So if we calculate sine C using the dimensions from triangle ABC, right, since the two angles are the same, the sines will be preserved, right? Sine C is just the opposite side over the hypotenuse, which is 15 over 38. So this ratio will end up being 38 over 15. And that's our answer. Right? If you wanted to prove this relationship using similar triangles, you could say, right, from here you could get BC over BD, right? And here you'd have to use the corresponding sides. You'd have to say AC over AB is equal to BC over BD. And here, if you plugged in AC and AB, you'd get 30 over 15 equals BC over BD. So it's essentially the same solution. It's just a different way of thinking about it, if you will. Here I've presented both ways of approaching this problem. I mean, it's up to you which way you feel most comfortable with. But either way, these two solutions are entirely valid. This was a good problem. It involved proving that two triangles are similar to each other, and then using that relationship to find the ratio of the two sides that we wanted. Right? And that concludes this part of the SAT Geometry Preparation Series. I hope you enjoyed this video and found it informative and useful in your SAT preparation. Share this video to those who are preparing for the June SAT or, SAT math in general. Good luck on your SATs, and I'll see you in the next video. Don't forget to subscribe.